I'm Alex Russell. I'm a software engineer on the Chrome team. And I wasn't always a browser developer. In fact, I sort of took the long way to get to work on browsers. Once upon a time, I was an OWASP volunteer. To give you a sense for when that was, I quit OWASP in 2003. So it's been a little bit longer, I think, than maybe for some of you since I did security on a day-to-day basis. And this conference is a little bit strange for me because it's sort of the return to something that I had spent so much time doing and loved, and then sort of took an entirely different track and now I work on Chrome for Android, right? Which is sort of not what you would expect. Before that, I worked on Chrome, and I worked on a product called Chrome Frame when I first joined Google, which is a plugin for IE, which puts Chrome inside of IE. That was kind of the thing that I cared about most. And before that, I did a bunch of open source JavaScript stuff. The last big project I ran was something called Dojo, which you may have heard of or now resent on the engagements that you do. But the common thread in everything is that I am a child of JavaScript in some way. Like Brendan spoke earlier today, and functionally speaking, without Brendan, I would not have had any jobs. I was not a great student. But JavaScript was the one thing I couldn't put down. He built it in 10 days, and then I spent probably the next decade trying to figure out how it all worked. And now I get locked in a room with him and Doug Crockford and many other folks for 3 days, once every 2 months, and we hash out what should happen in JavaScript next. And there's some good news there. Like, there's some great stuff coming. And I'm not going to talk about a lot of it today, but some of it's even security relevant. But that's how I got from being a web developer to working on the web platform. But in the middle, I did security. I was a web app security guy. I wrote IDS signatures for a living. And web app security was something that I always found a little bit disconcerting because it's the game that you can never win in the way that almost all security is. And so there's the initial elatement of finding the bug, right? You find the thing that you think is wrong. You poke at it with a stick, and you see if you can actually, make it bounce. And if it does, you get excited about that, and you're like, aha, I know a thing that nobody else knows. And then you try to twist the stick. Like, how far can I get? Like, what can I actually do with this thing? And so you pick it up, and you try and go with it. You try to build something malicious. You try to see how you can break this thing, and start stringing things together. And then, usually, it's not that the thing was broken. It's that the thing was doing something in an environment where it was granted a lot more permission than it may have been intended to have been given by its application developers or its authors, right? I think almost every major class of vulnerability that we operate with or try to defend against is effectively the same story over and over and over and over again. This is how you play the SQL injection version of this game. You find some string that was naively plopped into some query out of some unvalidated input, usually through string concatenation like this, say from PHP. And you just exploit the heck out of it. You go and you drop tables, you read data, you do whatever effectively the user of the database connection, the database connection's account had access to do, right, in order to get where you want to go next. OK. The XSS version of this game looks much the same, except you start from a springboard usually. You start from some content coming in from some place that wasn't sanitized, right? Story as old as time. And then you do something that the application author naively thought was in the interest of the user, right? So what we're seeing here is a story that keeps playing itself out. I took data from the user, I did something on the user's behalf, and now someone who is not the user is making the user's life hell as a result. We've all seen this 1,000 times. And the end game for XSS is very often, OK, let's go smuggle our data back out the back door. Let's go take it with us. Let's go put it someplace else. So we'll ping some other server. We'll upload the goodies to some other third party that we happen to also control. OK. CSRF, same story, right? I take some data. I find a bug. I do something malicious to some bit of context that the user had laying around, the browser thinks that it's acting in the user's interests, right? It's trying to mediate this conversation between multiple pieces of content, which are all attempting to ostensibly work on the user's behalf and try to guard them from each other and guard you from all of them, but give you value from them. And this conversation doesn't go well, because what happens here is that you, as a user, have authorized the browser to go have full permissions to whatever your set of authenticated sessions would have given you access to. And the thing about the same origin policy in this case is that it gives you access, whoever you might be, more or less, to that. So we defend against it by putting in session tokens and making sure that we try to authenticate each and every transaction and make sure that we can't replay them easily. But what we're starting to see here is a little bit of a pattern, right? The pattern is find an encoding bug, right? That's where it all starts. You find some encoding bug. You put that content in a context where it was given far too much authority over the user's behavior and the user's data. And then, based on that authority, you pivot and you turn it into something malicious. And this story is the same thing that we saw in C and C++. It is exactly the same sort of root vulnerability, the same sort of root story about the world that we need to come to grips with. So the options are that we can yell at the developers. We can tell everyone that they're idiots. We can evangelize that if they don't know how to correctly escape their content, that they don't deserve to have a keyboard, and we in our darker moments mull licensing development. Are you this tall? Can you ride this ride? Okay, maybe that's not potentially plausible. Maybe instead we say, okay, we'll just start patching these little things one at a time, right? We'll implement CSRF, we'll do escaping, or we could get serious. We could start to count on humans being frail creatures. We could start to believe that the pattern that has played out through the history of computing, which is that when you give people sharp tools, things get cut off that shouldn't have been, turns into the fundamental truth about computing, right? It is the economics of action. What is the easiest thing to do? Is it easier to build a secure system or not a secure system? Is it more straightforward for you as a developer to take the pieces you've been handed, assemble them in a way that hurts users more or hurts users less? Are you acting more often or less often on the user's behalf as a result of having combined the things that you were handed, right? This is the essential question that I think, as an industry, we sort of have to get our heads around. And I honestly can't believe that the right answer is that we tell everyone to go escape everything correctly all the time, right? There is some hope at the end of the day that what we can do is we can combine the economics of developer efficiency with the needs of security engineering and put most of our concerns into frameworks which are well audited, well understood, and eventually come down to, did you do it right or did you not do it right at a meta level, right? We can trust fewer people to do fewer things wrong. And that tends to work in some cases. But eventually, what we get to is this confused deputy problem. Not this confused deputy problem. Right. The one Norm Hardy fingered. So who knows who Norm Hardy is? Is this just me? One? Did I get two? Can I call two? Two going fast? No, two. OK. So in 1988, he published a paper which was a retrospective on some experiences that they had had in time-sharing machines. We would call them multi-tenant now, right? How quaint. Multi-tenant architectures. Time-sharing machines, which none of us would be able to recognize and fewer of us would be able to use a terminal at. But they had this problem, right? And in the Confused Deputy paper, Norm Hardy clearly distills down the idea that a user acting with the permissions that the user has been given in one context can be subverted by data, right? It can be subverted by some bit of behavior out of context, right? That now takes that user's authority, the thing that the user is, and turns authorization into authentication in environments where you have to go back and maybe look, okay, was this user meant to do this? So, okay, we've had several decades since this to contemplate our sins and come up with better ways of doing things, and have we? Sort of, right? We can look at the same origin policy, and we can start to think, right, so what we didn't do was give everyone on the planet the ability to install code directly when you visit a website. We did not do that intentionally. I don't know about people who are still running Java in their browsers today, but we didn't do that intentionally. But the net of it was that the same origin policy, which Brendan talked about today, gives us another form of ambient authority. Yes, we've limited the ability to have buffer overruns in most cases. We have taken many of the sharp and nasty edges off of developing GUI applications. And we've done it by turning it into something that is no longer a question between consenting stacks and heaps in an OS. And we've turned it into something that's being done inside of interpreters, inside of controlled environments that tend not to expose their guts. So that's good. But it leaves us with this problem where we, as we just covered, can subvert the will of the user, well, maybe not the user, but one of the user's agents at any given point in time in ways which are astonishing, and astonishing is usually bad. So we want less astonishment. So our approach is to mutual composition, which is taking multiple things which don't trust each other and putting them in the same environment and going, hey, great, now you have to work together. If you're mutually suspicious bits of content, how in the world are you supposed to get along, right? I embed an ad in my page. Today, we do that with script tags, as Doug mentioned yesterday. We include them with the script source, which effectively gives them full permission, right? This is ring 0 of the web. This is intentional XSS, as he framed it. And today, we just pray this doesn't really get any worse. That's really our strategy right now, has been to get out the rosary and start doing Hail Marys. Or we could go paranoid, right? This is where bank sites are today. SSL only all the time. All resources, no matter how inefficient this might be, no matter how much we might screw caching, no matter how bad this is for end user experience, we might go put everything on our own CDN or on our own IP, serve it over SSL, take no risk, take no chances, because that's the only way to be sure, right? Nuke it from space. No composition at all. You can't take third-party content and do anything unless it came through an effing proxy that we own, right? That is the paranoid worldview today. And that's where the high end of the market is. If you know you have a problem, this is where you go. This is what you do. Okay. Or we could break out the capabilities worldview, right? Which Norm Hardy alluded to in The Confused Deputy. But the basic idea here is that instead of saying, are you that user? Okay, you get to do the thing that I know that user can do. We say, do you have a key to open this particular door? I don't actually care who you are. If you've got the key, you can open it, right? Actually, you being you isn't an interesting part of the question. You could be anyone as long as you have the key to open the door. So what we do is we make keys for each door that you'd like to open. And we make the doors only as large as they need to be in order to get the job done. This is a basic part of reasonable security engineering, but it has a name. It's called capability theory. Capability theory is part of actor theory, but it's the right side of how to design large, multi-party systems that need to all be mutually suspicious, right? You hand someone not an authorization for everything that a user could possibly do. You hand them the authorization to do just that job that you're talking about. And you vend only those, and you can revoke them individually, hopefully. So there's a subdiscipline of OCAP, which I think both Brendan and Doug talked about. A subdiscipline of capabilities called object capabilities, OCAP, that Brendan and Doug talked about. A little bit in passing and a little bit obliquely. But the basic idea of OCAP is that the key you get handed isn't just some bit of strings. It isn't some random set of bytes. It's an object in your programming environment. It is whatever the first class object type is. And that thing now has the ability to go do those things. So you can call methods on it, and it will do them. It can perform those operations, right? But you get vended the object, not just some key to go do the object. You get vended the object itself, and you can use object-oriented programming to kind of go call methods and perform those behaviors. There's some history in this. There are systems that have been built. Doug's AdSafe is in the zone. eWrites, which is a language that came out of a startup that I think Doug was at, actually, with Mark Miller, was a distributed object capability system for Java. And Kaha is sort of a modern successor to that. It takes JavaScript and it compiles it, JavaScript, HTML, and CSS, and it compiles it into a world where all of the code that you run through these systems lives in their own sort of isolated world. Yes, they are all running inside of the same virtual machine, but they all live in what they believe is a totally isolated environment. They can be handed things from the outside, and they can hand things out to the outside, but they only have authority over what they've been given access to. So I'm not really an object capabilities fan. I don't think that this is the way forward. I am, however, an enormous fan of the basic premise of capabilities, which is that we should be handing out keys for just the things that you're trying to get done, and the doors that we open should only be big enough to do the jobs that we're trying to get done. We shouldn't be opening man-sized doors. We should be opening, like, am I trying to send you a letter? It should be a letter slot, right? That's kind of the way to think about this. But OCAP instead encourages dense webs of objects, right? You get an object, and then you get another object, you call a method, you get an object back. Basically, everything in your environment is an object all the time, right? So how do you know, then, which are the secure objects or the objects that you need to think about? Which are the ones that you can sort of be a little bit like, yeah, whatevs, man? Because the reality is that day to day, we're not paying a ton of attention to all the interactions of all the systems that we build. It's just not plausible. I mean, who in here is DJB? Like, did he show up today? Because he's it. He's the one. He's the one person I know of who has spent the time to sit down and think about the potential causes and outcomes of effects on his systems when he builds them. The rest of us don't do that, mostly. We build systems to get a job done, and we make a ton of assumptions. We tend not to go write out all of our assumptions longhand ahead of time, because eventually it comes down to you got to trust someone. So the way we most often build systems is to start with something that works and tweak it a bit. And then we tweak it a little bit more, and tweak it a little bit more. And that's how we got pretty much everything we do today. Yesterday, Doug Crockford made the case that it was a terrible thing that web developers just copied and pasted crappy code from GeoCities or wherever, and they view sourced, and they took whatever junk was on the web and they put it into their web pages, and isn't it a calamity because now we've got incompetent people building stuff. My view is fundamentally, diametrically opposed to Doug's. Isn't it effing amazing that we gave people who had no ability to build anything before the ability to put stuff on a computer screen? Isn't this like the most liberating thing we've done as a set of people in pretty much ever? This is magic. This is gold. We should do more of this, right? And then it's up to us, the people who are providing the platform, to help come up with ways to preserve the invariance, the security, the safety, the statelessness, the ways that you take these pieces that you're given, put them together any which way, and get something out the other side which more or less is secure, right? We have to start describing the world that these things can live in a tighter and tighter fashion, not say, no, you shouldn't be able to do that. Because like everything, we're going to continue to evolve. There was a great study out of UC Berkeley on a user interface toolkit by a guy named Jeff Heer. And this user interface toolkit was built for data visualization. And you should probably go check out Jeff Heer's work, but if you like shiny graphs. But what he got to at the end of it was a study of developer habits, right? He took 3 different classes of developers, sort of noobs, advanced developers, and then experts, and sat them down with documentation and code samples. And in every case, every single case, everyone took the code sample, they copied it, they pasted it into an editor, they tweaked it till it worked, and then they started making changes. This isn't how noobs learn. This is how we all learn. This is how we build everything. We need to get over ourselves. We're not so badass. We learn the way everyone learns, right? Okay, so let's acknowledge that we're human for just a second. Let's get over our bad selves and acknowledge that we learn things progressively. We're better, hopefully, today than we were yesterday. We are going to have made mistakes. So we need ways of structurally preserving our ability to recover from mistakes. I discount the probability of perfection 100%. I don't think it's plausible to posit a world in which our best advice to developers is don't make any mistakes, right? And we've seen how this has played out, right? What is the biggest change in the security posture of the computer industry in the last, we'll call it 20, 25 years? Interpreted languages or jaded languages. It has nothing to do with developer methodology, although that's critical. It's enormous that we were able to get the right people who are still playing with knives to get to understand the responsibilities that they've taken into their own hands. And as a C++ engineer day to day, I understand. This is some scary, scary stuff. You should be afraid line by line when you're typing it out in C++. This should actually rock your boots a little bit. But for everybody else, we moved to .NET, we moved to Java, we moved to JavaScript, we moved to Ruby, we moved to Perl, we moved to Python. We basically took the advanced weaponry out of the hands of everyone and said, you know what, you don't need to learn how to build a thermonuclear weapon in order to go and defend your house. These are not isomorphic tasks. They don't go together necessarily. So let's not start teaching global thermonuclear warfare when we could be putting locks on doors, right? So I think what we need is a structural approach to how we're going to start securing the web, all right? And it's worth noting that there are some things that you can do from the leverage point of an organization who is trying to defend itself. There are some things you can do from the point of a developer who may or may not have enough time to actually consider all of the consequences of their actions. And you're only responsible for the predictable consequences, and even then under other constraints. And there are only some solutions that you can approach and problems you can bite off when you're on the inside, when you're the platform provider, right? So a lot of things I'm going to be talking about are things that pretty much only browser vendors can do. But I'm talking about them because they're the sorts of things that we should be doing as browser vendors. And to the extent that we haven't done them before, we may have been failing the entire web. Let's not reflect too much on that. So I think the goal here is to remove ambient authority, right? To start handing out keys and not asking who you are. Because the idea of knowing that Joe's a good guy doesn't really scale. You don't really care that Joe's a good guy. You care that you got the key card to get into the room. Because staffing someone who knows everybody who checked into the hotel in front of every room just doesn't work well. And it's easy to confuse that person. That information doesn't travel well or quickly. And well, was that the right Joe Johnson? Was he allowed into the presidential suite, or was that the Joe Johnson who got in on some sort of a travel voucher, right? Like, which room should you give this guy? So you actually have to come up with a better system. We need to trust not people, not even authorized actors in the system, but authorized individual actions. And we need to understand that we're not going to change everything. There is no silver bullet in security. There never has been. There never will be. The things that we will make better incrementally. It is worth being frustrated about the things that we can't and the things that we won't make better soon. But it is not worth being frustrated about the fact that you can't make it all better now, right? So our job is not to muddle. It's to make intentional progress and change in the areas that we can, but never to write off the possibility of change and never to discount the idea that we are the ones who can change it. So it's worth noting that defaults have a lot of power, and the ambient authority that the same origin policy gives to every piece of script, to every piece of CSS, to every font, to every resource you load into every web page today, with regards to the origin that web page was served from, is something that happens by default. It's just the default policy. We can reason about this a little bit differently. Like, if I was on the server and I said, oh, I got something from origin such and such, I don't want to serve it to them, right? The server can start to make those sorts of judgments. But the client, because the default is set a particular way, yeah, maybe you could start to do something if you were watching all of these, if you were being very careful about what you served. But again, that's putting us back at this ring zero of, okay, now be perfect, right? So we can't assume that everyone's going to be perfect. We have to change the defaults to get better behavior. So we have some primitives that I think are workable. Web workers, which I'm not going to talk much about because I don't think they're really kind of a security primitive, but they sort of give us the same API. Web intents and iframes. I think web intents and iframes are really the things that we're going to be able to use on an ongoing basis to secure most of the rest of the web. And we do it by taking those nouns and combining them with adjectives. Cores, for one, which gives the server some ability to participate about how it wants the client to behave when fetching resources. Content security policy, which may be the single most important thing that we've ever done in terms of web security, and sandboxing, which goes hand in hand with CSP, and you'll see what I mean in just a second. Does everybody know what these are, or is this? Cores, CSP?
What is cores?
Well, what is cores? Cross-origin resource sharing, yes. It's an HTTP header that allows you on the server to claim which domains should be allowed to load particular resources. It doesn't work for all resource types. It doesn't work necessarily for scripts, for images, for a lot of things that have been grandfathered into the same origin policy, which causes it to be potentially less effective than it could be otherwise. But servers are already in a privileged position. If you can watch the refer, you can already decide to deny requests. So the question is whether or not you trust that. You'd like a tighter policy for some things. Cores today is mostly being used to do tainting for things like Canvas image data and to prevent particular businesses from being disrupted in the font space. So CSP, content security policy, allows you to start turning stuff off by default. As an individual web page, you can now say, I don't want fonts to be loaded from some particular set of URLs, or I want them to be loaded from some particular set of URLs and none else. I wouldn't like iframes to be allowed. I wouldn't like them to load from particular domains, or I would like to whitelist particular domains. I would like to only load images from a particular location or set of locations over a particular protocol, styles, all kinds of media. It's weird that media and images are separate, but let's just note that as a historical weirdism. And we've got some control over how strict we would like that policy to be. So we can start to turn whole swaths of browser behavior off. And I think the most important of these is the ability to turn off inline scripts and the ability to turn off the requests to URLs and domains that you didn't mean to. Because that enables you to start clamping down on the entire world of opportunities that an attacker might have. If on the one hand, they can't get their malicious script loaded from a third party, or if they actually are able to XSS you, but they can't report data back out or pull in any help from the outside world, that's not bad, right? Now we've started to cut off some of the avenues, some of the things that were being abused because they were just sort of latently sitting there in the world. And the next version of the spec is going to allow us to clamp down on what form posts can do, which I think is the other big gaping hole right now. CSP 1.1 is about to be announced. CSP is actually relatively well supported in modern browsers today. My recollection, and I would have to go look at the can I use table for this, but I think IE 10, along with Firefox, Safari, Chrome, have CSP today. Old versions of IE are a little bit hosed. I recommend you opt your users into Chrome. So we can do things like say, I would only like SSL served resources on this page, right? That's outstanding. Or I would like to turn off the ability for scripts to be loaded directly as text in the web page. I'd like them to have to come over an HTTP connection. And then you can then lock down the set of domains from which you can load those resources, right? This allows you to turn off a huge chunk of potential vulnerabilities. Someone's able to put a script tag in your page. Well, it doesn't matter. If you had an event handler that was inline, or you had an eval, or a script tag, and they put it in there, you just turned all of that off. You just turned off the entire vector through which someone was going to make your life hell, right? XSS is effectively dead in the water with the right CSP policy. Now, this is difficult potentially for adoption. One, you have to have control over the headers. This, for many organizations, is a huge challenge. Saying to an organization, you should standardize on a policy, is a little bit difficult. And at the same time saying, and now your developers need to be able to send arbitrary headers. In many environments, that's unworkable. So I don't necessarily have a silver bullet for this, but I think CSP is the future here. Because it allows us to do things like just grant in the set of third-party content that we would like to cooperate with, trusting them as though they were actually part of a pound include in our web page. It's just now something that we can assume. Because let's face it, the root of trust on the web today is actually third parties. Like, we do trust third parties almost congenitally. We do it for analytics. We do it for like buttons. We do it for tweet this. We do it all over the place. And it's almost impossible to browse or use the web. Third-party AJAX CDNs in order to improve performance, to get better caching, right? We are intentionally XSSing ourselves. Oh, I'm sorry, I forgot to mention ads, right? The set of places where we rely on third-party content today is vast, and the web probably wouldn't work without it. So we need the ability not just to say turn it all off, but to turn just some of it off. And then to close down the holes so that we're only handing out keys for things that are big enough to do what you meant them to do, right? The idea of running an inline script on your top-level web page may not be something that an ad should necessarily be doing. OK. So for organizations that are having a difficult time adopting CSP, there's a report-only version of this, which is great. The bottom example there shows sort of how to do it. You give it a report URI, and you say, you give it a relatively permissive policy, default source is self, and you allow all sorts of other stuff. You don't turn off most of the other things that you might otherwise. And what happens here is whenever there's a violation of your policy, a JSON formatted object is sent to that URL. So the easy on-ramp here is, OK, let's assume that you can't opt everyone in the world into this for your sites or for your applications. You can at least get a handle on how often you're getting owned, right? How often am I getting XSS'd? If I had turned this off, I meant to do this. I wanted to build something that worked this way. How would this work? This is good stuff. So going along with this, I said that the iframe is one of these composition primitives that I think we should be leaning more heavily on. And I say that not in an unmitigated way. It's not possible for us necessarily to talk about iframes without acknowledging that with same origin, all hell breaks loose with iframes, right? CSRF is a huge hole with iframes. You can request all kinds of random stuff. Iframes are the sort of things that users really understand. They don't have any secure UI. We use them all over the place. And when they are same domain, you get into all kinds of shenanigans. But what the sandbox property does is it says, even if this thing came from the same domain, treat it as though it's a third-party domain. Break that same origin link with the content that's being hosted inside of it. Treat it as though it's a third-party origin, which means that now the only way to communicate with the content hosted inside of that iframe is postmessage. And so postmessage is wonderful. Postmessage is a godsend. Postmessage is the way we talk to web workers. It's the way we talk to third-party iframes. Postmessage gives us a way to just send inert data, actual data, not code, not anything else, but through the structured clone algorithm, we just send data, which means that you now have a message passing boundary over which you can start to build a protocol about the set of things that you would like to do. This isn't a capability system, but it's the guts of what you would need to put this capability system together. It's just the pieces that you would start to construct this world out of. You need to build your own little protocol to do this. But the nice point here is that once you've got an iframe sandboxing system that allows you to turn off all sorts of things and turn them on selectively, and you can communicate with that content in a relatively secure way where you're not throwing your entire top-level environment into risk every time you want to have a conversation with some piece of content. As long as you know that this is a big, chunky object, it's a thing that I'm having a secure conversation with, as a developer, you have low enough complexity to reason about it. It's not just every other object in your environment. It's one that you're communicating with a little bit specially. Like, it's going to be asynchronous, so you have to sort of learn how to use postmessage, which means that you're going to have to treat this thing a little bit specially no matter what. This is great, right? We've thrown all the big, this is different, this is scary, this is something that you're going to have to learn flags into a developer's face, so that when you want to make content work together, now it's easier for you, as long as you're mandating the sandbox flag on your iframes, to convince developers that this is something that they need to be very careful communicating with. And the default tool that you've given them to communicate with it through is something that by itself isn't going to own you left, right, and center, which is great. And now we've got the seamless iframe, which is now enabled in the latest Chrome 22. I think it's out. And you can combine these. And the seamless iframe solves the biggest problem that most iframe-based systems have, which is that they've got content which has its own intrinsic size. And you, as the parent web page, wouldn't necessarily like to clip it, and you wouldn't like to put scroll bars on it. So what do? The seamless iframe allows that content to take up its natural size in the parent page and to have the parent's styles cascade into it. So if you want to set common header or footer colors or backgrounds, you can do that now with the seamless iframe command. It's unfortunate that it's not better supported on other browsers. But I think we're now at a point now with seamless iframes and CSP where we can talk about not really dealing with other origins if we choose not to. Right? We can have a conversation about, OK, I closed everything off. Now I want to have a conversation with some third party. What do I do? Right? And that third party conversation is now something that you are doing intentionally. It's something that you can start to vend a capability for. You can start to have a conversation about what is it that we're trying to get done here without opening yourself up to everything that could possibly go wrong just because you wanted to get a little tiny thing done. So I think the last composition primitive here is web intents. Web intents are new. They are on default by default in the latest Chrome. And the basic idea is that they're like Android intents. Basically, they're an asynchronous call to a service which may or may not be registered in the user's browser. Right? You may have said, I would like you to do a thing. And you name the thing opaquely. You don't say, go do it this way. You say, hey, any random third party, please go do it. And if it isn't there, please show me how to do it. So this is webintents.org. And this is a tiny little demo. So let's see. If I try sharing something now in Chrome, why didn't that load? Weird. Huh. I think it's the external display is making my thing unhappy. But long story short, I get a list here of, I'm very sorry about this, I would get a list of extensions from the Chrome Web Store which would match the share intent name. Basically, they said, hey, we're the best ones that are rated in the store. And for instance, I don't know if it's taking clicks. No, it's not. I could, for instance, share something through Twitter or through some other service. And that isn't a visible conversation for me as the app author. I just said, hey, user, go do it. And I've given the user the ability to both choose how they want to get it done and to give me a response from the other side. The only thing that has to happen is that both sides of that conversation have to fulfill the intent contract. And that's an ad hoc thing in most cases. That's something that evolves out of the marketplace. So instead of you saying, hey, Twitter, I want to share with you, you say, as a user, I would like to share something. And then the browser provides the indirection for discovering how it can be done. And we just provide the result back to the service that chose to do it. The standards effort for this is ongoing. But this opens up, again, a brand new way of thinking about how to structure second and third party collaboration. If you don't trust the other folks in this environment, it's no big loss because the user is in control. They get to register who they would like to do something with. And when they haven't registered a handler, they're presented with secure UI about how to make that conversation. And that's something that we as a browser can get better at over time. We can start to learn, like we do with phishing, oh, this probably isn't a secure thing for you to be doing, and we can start to help users out. We can also eventually killbit nasty intent providers that have been served through the store, which is good news. OK, so a lot of stuff I've been talking about doesn't work in old browsers, and I would like to convince you today that you shouldn't care. And I don't mean that in the sense that you shouldn't care about your users. I think you should absolutely care about your users, which is why you should be in their face about getting a modern browser. This is not in a world where exploits are being reverse engineered effectively day of patch release. This is not really the kind of thing that we should be thinking is an optional thing to do, right? Secure code is up-to-date code. And up-to-date code will soon not be up-to-date code, and therefore the window of vulnerability will rise for whatever it is that we just deployed. So The most important thing about a browser today, from a user experience perspective, from a developer perspective, and from a security perspective, is its half-life. How long does it live when it should have been replaced, right? How much damage could it potentially do? How big is the window of vulnerability that it has cracked open? Chrome is doing a leading job today in shutting that window behind us as soon as we have a new version out. And I'm super excited that Firefox has joined us in that, and happy that Microsoft is making big strides in getting their users to auto-upgrade quickly as well. But if your users are on old browsers, I believe that the best thing for you to be doing as a web application developer, as someone who is consulting in organizations, is to help them understand the gigantic risks that they're running and to get in their face about making an informed choice. Maybe you can help inform them. I don't think that we can go advocate that people write perfect code, but I think we can advocate for structural solutions like auto-updating browsers and defensive design and large nubby things which vend capabilities to each other, but which don't imply that everyone has to be perfect all the time. I have a lot of faith in our ability to construct systems like the Chrome sandbox, where you don't trust things by default, and then you have a very small channel that you send a set of task-based messages through. And we can build protocols that are small and task-based enough to get the job done, and that we can design defensively based on inert data coming through channels that are purpose-designed, not trusting users, and giving ourselves the tools and the permission to advocate using the tools that will make our lives better. So, okay, I just want to end by showing you the next version of the Chrome apps platform, Chrome packaged apps. So we've been building the Chrome apps platform for a couple of years now. It came initially from extensions. But the basic idea is that you have a new tab page in your Chrome, and maybe you have a calculator, and you load your calculator. But in this case, this is a free-floating window. It's not just a tab, which is a nice feature of the new apps platform. And in this case, it's worth noting that in apps version 2, this is an iframe that has a link to a source of my blog today, but it's not loading anything. And if I go back to the web inspector, these are built, by the way, in HTML, JavaScript, and CSS. You can see that it violates the CSP policy. The CSP policy, by default in apps v2, doesn't allow inline scripts, and it doesn't allow iframes, effectively, which means that we've turned off the biggest risks in apps v2 of XSS. So you're not allowed to effectively use iframes. You're not allowed to use inline script handlers. You must have your scripts as external resources, and you can't use eval, right? These restrictions mean that, functionally speaking, if you've got third-party content coming into your thing and you do have XSS, you're in a much better place to be able to fight it off in an apps v2 world. And we're insisting in these applications that you can't now specify a policy that's weaker than that, which I think is fantastic. It means that all of these apps are going to be more secure by default. And what's the carrot? I mean, that's the stick, but what's the carrot? The carrot is that you get this beautiful integrated desktop UI behavior that's portable. You can build apps in JavaScript, HTML, and CSS. They can work on any platform if you choose to make them that portable. And they can have control over their windows, and they can install services. They can do all sorts of things that regular HTML web pages can't to help build better, stronger user experiences, not just more secure ones. I realize that I'm out of time, but thank you for your attention. And I guess I think I don't have time for questions up here, but I'll take questions I think as we filter back to the hallway. Thank you.